All right. Oh, all right. Oh, hello there. I am Scott. This is Rebecca. And we are from A Class Tutoring. And this is just the free trial class for you guys. 大家好，我是 Scott，这是 Rebecca，这是我们的免费公开课，A Class Tutoring 的免费公开课。Okay, so would you like to introduce the case, Rebecca?
So, for an example of how our teaching style works, we try to integrate real life medical cases with the scientific concepts that we're trying to teach. So, for this example, we have our patient for today, Stephanie. She's 56 years old and she's experiencing difficulty breathing, chest pain, and she feels like fainting. On top of that, she's also confused and tired. So, as a doctor, you request a blood sample from the patient and you get the following results. Her pH is low, her carbon dioxide is high, and her bicarbonate is low. So, we know from her struggle of breathing that this has to be some kind of issue with her respiratory system. So, the respiratory system involves a lot of processes. It's not just getting air in and out. It's finding a way to get that air in efficiently, getting that air from our lungs into our blood, moving that blood around, swapping the oxygen for carbon dioxide, getting that oxygen where it needs to be in all kinds of other tissues, and then getting rid of the carbon dioxide. So it's a lot that our respiratory system needs to do, and there's a lot of opportunity for it to go wrong throughout the way. The simple anatomy of our respiratory system involves the lungs, the trachea, and the diaphragm. These are the three most important parts. First of all, we have the trachea, which is more commonly known as the windpipe. It's like right in your throat. Got two pipes, one for food, one for air. And this one is where your air goes down and it splits into two to go into the two different lungs. And our left lung has two lobes and our right lung has three lobes. And can anyone tell me why that might be? Yes, because our left lung has to make room for the heart, which is on the left side of our chest. And the heart is involved a lot in the respiratory system too, because that's how we move our oxygen around our body. And then below the lungs, we have the diaphragm, which is probably the most important muscle for breathing. What we use it for is basically it goes flat to make there be more space for the lungs to expand. So if the lungs didn't have anywhere to expand into, the air wouldn't have anywhere to go, and we wouldn't be able to breathe in unless we put in a lot of effort. So in our patient Stephanie's case, it's taking her a lot of effort to breathe. So one reason could be that her lungs don't have anywhere to go. So how the diaphragm does that is it goes from that sort of rounded dome shape to a flat shape, and then there's extra room for the lungs to keep expanding. Here is just another angle of how the diaphragm does that. So the diaphragm in its relaxed state keeps the lungs squished together to push the air out. And when the diaphragm contracts, it means the lungs can expand more and air can come in. And then deep inside our lungs, I feel like a lot of us think of lungs as just like these empty bags, but it's actually like a pretty dense tissue. And deep inside, we have these things, they're called alveoli. They look kind of like little balloons, and they're really, really thin. Like the walls are really thin so that the oxygen can cross over really easily. And it's surrounded by these little arteries that will take your blood. And what happens here is the gases switch over. And so this is another place where Stephanie's issue could be arising from. If her alveoli are too thick, maybe the gases won't be able to go across. So this is just a summary of what we've kind of gone over already. The air needs a driving force to get inside. So that's why when it's hard to breathe, you feel like you're putting in a lot of energy to try and breathe. It's because your body isn't able to produce that driving force anymore, so you have to produce it yourself. Naturally, it just comes from the diaphragm flattening. But if you have an issue like Stephanie does, it makes breathing really, really difficult and take a lot of energy. So in our case, we have a few ideas of what could be making her struggle to breathe. It could be an issue with her lungs not expanding. It could be something with her diaphragm not flattening, or it could be something with the alveoli being too thick.
Right, so I'll take the chemistry part regarding Stephanie. So respiration is inherently a very chemical process. You're inhaling carbon dioxide. Sorry, you're exhaling carbon dioxide and you're inhaling oxygen. But respiration doesn't stop at that because carbon dioxide, as we'll get into later, has some unexpected effects on your body. So starting off, we're just gonna define what acids and bases are in order for you guys to sort of get like a basic grasp of what's going to be happening to Stephanie. So acids, in this level, we define it as substances that donate hydrogen ions being represented by an H. They usually have hydrogen ions bound to non-metal atoms. An example of an acid would be hydrochloric acid, HCl, the Cl being the non-metal item and the H being the hydrogen ion. And then there's also things like nitric acid, sulfuric acid, which all follow this sort of same pattern. And those are going to be some of the common um, some like the common acids that you will encounter. Bases are substances that remove hydrogen ions from a solution. So they can be a lot of things, like bases are a lot more complex than acids are, but generally they contain metals with oxygen, metals with carbonate. So the way they determine if something is acidic or basic is by with the pH scale. So you have the scale going from 0 to 14, which measures how much hydrogen ions are in a solution. So the lower the pH, the more hydrogen ions it's going to be, and the more acidic the acid is. On the other hand, the higher the pH, the less hydrogen ions it's going to have, which is a little bit counterintuitive, but that's just how whoever invented the pH scale decided it's going to work. So then the more basic the base is going to be, so the less acidic it's going to be. pH scale is logarithmic, which means that let's say like an acid with a pH of 2 would be 10 times more acidic than an acid with a pH of 3. So with each increase in pH, it will be a 10-fold increase in the hydrogen concentration in the solution. So likewise for like a base, something with a pH of 12 would be 10 times more basic than acid, than a base with a pH of 11, because that's just the logarithmic nature of the pH scale. There's a lot of debates on where the P came from, because the H obviously stands for hydrogen, and the P, some people say it's power, which would like explain why it's logarithmic. Anyhow, the colors on the chart right there is the color of this solution we have called the universal indicator. At no point in your course are you required to know what the universal indicator is made up of. Just know that the universal indicator is commonly used to detect how acidic, neutral, or basic something is. It's like a dye for solutions. So acidic things, when you put the universal indicator in, there will be red, there will be yellow, neutral things will be green, and basic things will be blue, and then the most basic things will be purple. So basically, the neutral range is like 6, 7, 8 around in the middle, and then the acidic range is just like 0, and then they'll be really red, and then the opposite for the basic. Yeah. And so let's take this information into the body. Your body, specifically your blood, is very delicate and it's very fickle. It needs to maintain how acidic it is. Otherwise, basically, your kidneys stop operating. Your kidneys essentially are controllers of what's in your blood. They filter out any toxins, any bad things, and they also adjust how acidic your blood is with bicarbonate, the most important base in your body, as I'm shown on the side here. And yeah, so if you don't have that ability to regulate acid and base, you will have your blood becomes too acidic or too basic. It gets to your brain, and then you will get dizzy, you'll start to lose consciousness, you'll get really slow heartbeats, and then eventually your heart fails, your brain fails, everything shuts down. So it's not good for your body to be too basic or too acidic. And your body maintains how acidic or basic it is with bicarbonate with the formula HCO3 minus. The H is hydrogen, C is carbon, O is oxygen. So this has one hydrogen, one carbon, three oxygens. And the minus is just the charge on it. At this stage, it's not too much of a worry, but if you're doing enroll in the class later, we will obviously go depth into these sort of things. So bicarbonate is a base. It accepts a hydrogen and turns it into carbonic acid. This is a hydrogen ion. This is bicarbonate. This is carbonic acid. So the way to read acid-base equations to determine whether something is an acid or a base is if the hydrogen ion is on the left side of the equation, it's being taken up, it's being absorbed. So that would mean that the compound on the left side is usually a base because it's taking up the hydrogen. If the hydrogen is on the right, that would mean that it's being made. So the right side is the products, the left side is the reactants. Right side is where you end up with, left side is before, or you have in the beginning. So if a hydrogen is made afterwards, then the starting product is probably usually an acid. So in this case, we can see that from this sort of chemical equation that HCO3 bicarbonate is a base and that its counterpart, carbonic acid, is an acid because it's able to make hydrogens. And the double arrow, by the way, just means that this reaction can go both ways. So yeah, so you know you can have bicarbonate turn into carbonic acid, and carbonic acid can also turn into bicarbonate. So back to Stephanie, sort of. When you have carbon dioxide in your body, it will react with water to make carbonic acid. This means that carbon dioxide inherently is not acidic, but it's able to combine with water to make an acid. And therefore, if someone, let's say it was Stephanie, had too much carbon dioxide in their system, they will make a lot of carbonic acid due to this reaction that we have on the whiteboard here. And as we know before, the carbonic acid is an acid, so it can donate hydrogens like so. So then their blood will have a lot of hydrogens in it, their pH will drop, and this person will become acidic. So back to Stephanie, she's not breathing well. She has lots of carbon dioxide in her blood. Does this affect how acidic she is? And the answer is yes, because as we have seen before, carbon dioxide reacts with water to make carbonic acid, as shown here. The carbonic acid is an acid, so it can donate hydrogen ions like this. Stephanie is acidic because she has lots of hydrogen ions in her body. So let's just jump away from the high school curriculum and just talk a bit about uni stuff. So in the clinical context, when your blood is acidic, it's known as acidosis, a state of acidity. For Stephanie, because her acidosis is caused by her breathing problem, she's not able to get enough carbon dioxide out of her system, which then turns into carbonic acid. This presentation is called respiratory acidosis, respiratory meaning breathing, basically in this context. You can also get other forms of acidosis, the most common of which is metabolic acidosis. So that will be when you're breathing normally, but your kidneys fail to make enough bicarbonate to neutralize whatever is going on in your blood, to take away the hydrogen ion so that your blood can remain neutral. So that's metabolic. Metabolic usually means kidneys in this case. And respiratory means breathing. And by the way, this stuff comes up essentially in every single year of your medical career, including first year health science. It's just overwhelmingly common. And one of the most common presentations in the ED scenario is some form of renal failure, which would then cause metabolic acidosis or alkalosis. Alkalosis means too basic. Basically, it's the opposite of acidosis. And that could also have a variety of causes that we can discuss into later if you are enrolled in the class. So these are our teaching philosophies. Rebecca will take over.
Yeah, so as we demonstrated just before, we aim to integrate clinical cases into our learning, and we do that to keep it both engaging for you guys and also to make sure that the greater idea, greater picture of medicine being the goal is always like embedded in the classes, I suppose. It makes it so that the learning doesn't feel meaningless or like it's just for a test. It's actually for your future and to help people. And similarly, on that vein, we'll be providing advice from our experience and pathways into medicine to help you guys out with that. We also encourage like thinking differently, taking time to use logic as opposed to just memorization, because memorizing can get you far, but it can only get you so far. And once you get into university, you need to be able to fully comprehend and understand and use your brain as opposed to just your memorizing. So we're trying to encourage critical thinking with our teaching method. And then finally, we'll also teach skills to stay calm in high pressure situations like exams or all of health sci first year. We'll be teaching some well-being skills, some test taking strategies that really helped us.
So in the case that you do enroll, these are the expectations that we have for students. First of all, pivotal for engagement, we require the cameras to stay on during the sessions because we want to see the students being engaged. We want to see that they're focused on the slides, whatever it may be, and that they're just actively partaking in the session, which is going to have obviously positive outcomes. We also want to see your faces and just get to know you guys better because hopefully we're gonna, like these classes are going to be small, so that we are like very close to each other sort of thing. And then if you can match up the face to who you are, then we can sort of get to know each other better and then, dive deeper into whatever you need.
Mm.
Also obviously we need to hopefully you guys can stay focused and motivated that our classes are interesting and to just sort of pay attention to content because you have to put the mahi in to get the treats, right? And in terms of putting the mahi in, we would hope for you to complete your assignments on time, which we would assign on a regular basis in like a variety of different flavors, I guess. There could be quizzes, mostly multi-choice research projects, look up especially specifically endometriosis and how it works, and SAQs, which is like short answer questions. These are sort of the diet in your uni level education. This is usually how it tends to work, especially in first year. So we're just going to try to replicate sort of like the medicine experience for you guys so that you can be more used to it later. We also expect you guys to ask questions either during the sessions, after, directly, indirectly in the group chat, into us, into our DMs, on the Zoom chat, anything. Because if you do ask questions, we can tell immediately what you need help with, and then we can sort of like build a personalized regime for you or your kids. And I just think that, because everybody's different. Someone might struggle with organic chemistry more and have no problems with like acids and bases, for example, and someone else might be the opposite. So it would just be really good if we know what your weaknesses are so we can work on that. And obviously that's sort of in the same vein as communicating your challenges early. And finally, we'd just like to for our students to build good habits, good study habits with guidance from the two of us to allow for your future success. Because once you're in university, when the workload is absolutely overwhelming, you have not a lot of help apart from your thought process and the thought patterns and the ways that you deal with things. So it's just good, really good to build a solid foundation into later tertiary education and whatnot. So these are just showing how we follow the IGCSE syllabus from year 9 onwards, because that's just more effective. It covers a wider range of a bigger scope of subjects, better topics within the subjects as well, and I think it just rewards students better.
And it encourages comprehension more than NCA does, which would prepare you better for health science and medicine.
For sure. And so yeah, the sciences will be divided up to help the students familiarize themselves for high level success, because university and first year alike are sort of like Cambridge style education.
So currently on offer for term 4 of this year, we'll have a year 9 and 10 biology, a year 9 and 10 chemistry, and then a year 7 and 8 general science. And if you feel like you need extension beyond your year level, you can apply for the class up on qualification. So that will involve just like a brief test to make sure that you are ready for the class above. But we want everyone to be reaching their full potential. So we definitely do encourage people to apply for the class above if they are feeling like they need to be extended. Then next year, when we have a bit more free time, because we'll be out of university and into the hospital,
Yeah.
we'll open up some more classes like a UCAT class, which is the med school admission test, and then year 11 and 12 biology and chemistry, and then if there's demand for a physics class throughout the whole high school years.
Yeah, and that's the end of our mini case presentation and whatnot. So yeah, we hope to see you at the enrollment and whatnot.
Yeah.
谢谢大家参与我和 Rebecca 的这个免费公开课，然后希望能够在第4个学期的时候看到你们，谢谢。
Thank you.